go. Here we go, here we go, here we go, here we go, here we go. Here we go. Here we go. Here we go, here we go, here we go, here we go. Here we go. Here we go. Here we go, here we go, here we go, here we go.
Hello.
Wow. Look at this couch.
You're the only one on it, apparently.
I mean, everyone is on it, right? This is
sectional.
That's right, the sectional.
There's a chaise over here. Somebody's got a Barca lounger.
It's pretty great. Wow. I don't know. We may have had this many before, but I don't think so. I think this might be a first. But the list of what we're going to talk about, or the topic itself, is, I think, it's deserving of this many participants, because this is a big topic. So, Adam, what are we going to talk about?
Well, hopefully I'm not freezing right now because my computer doesn't like me. But we are talking on-premise today, on-premises, and what that means. Am I choppy? It feels choppy to me.
Yeah,
You're
you're choppy.
Yeah.
A little bit.
But I love how you covered all your bases there. On-prem, on-premises, on-premise.
Wanted to make sure I checked all the boxes.
That's right.
But why don't you take over, because my computer's acting funny. So Brent, continue for me, please.
No problem. So, especially as part of reInvent, there have been a lot of announcements. There's a lot of development and movement around how can you run your containers, in a place other than your typical AWS region. So there are a ton of developments in that area. So we thought, we should just have a discussion about what are the options today, because the way things looked 6 months ago is very different than the way things look today. And there could be some benefit to you in evaluating what your options are today. So let's just talk about first, what is the tried and true? What options do we have? What options might you be using? Justin, I saw you.
I was thinking we should introduce Chandler, and even Massimo's not on the show very often.
That's right.
Just in case people.
It's Massimo's first time. Yeah, you're right. My bad. Let's introduce
Big deal.
Massimo and Chandler. Massimo, who are you?
I'm a little bit nervous because this is my first time on the container from the couch, so bear with me. I'm part of Team Container, just like everyone on this call. I've been with AWS for about 3 years, slightly more than 3 years. Started as a solutions architect and moved into the DA role a couple of years ago. And prior to that, I've been working at VMware, working pretty much on containers in the last few years during my tenure over there. So that's me.
I hear VMware has a lot of on-prem customers.
I would say the majority.
Just saying, you have some experience there.
Yeah, even though I've been working with on vCloud Air and vCloud Hybrid Service and all those sort of technologies, but maybe over a beer next time.
Nice. And Chandler, who are you?
Who I don't know who Chandler is some days, but no, I came to AWS to help with specifically the Kubernetes stuff we're going to be doing on-prem. So my team works on EKS Distro and EKS Anywhere, which we'll talk about today. EKS Distro being a open source project that I'll shamelessly plug right now, find on GitHub, and then EKS Anywhere, which we'll talk about a little bit more today. So I've been, bounced around the container world for a little while. I was a customer, buying container orchestration platforms when it was all the rage. And then I went to a vendor. I worked at Mesosphere for a while and experienced it on that side. And now I'm excited to do it at AWS.
Nice. Awesome. So yeah, and Chandler, do you still have open recs looking for engineers?
Absolutely. Always have open recs. So yeah, maybe I'll find the link while you guys are talking and post it in the chat. But we definitely apply. It's not as hard as people think it is. It's
Yeah.
I mean, I got in here, so.
And it's a great team. It's a great group. It's a great group to work with. So
Yeah, apply.
Yes.
nice. All right. So if we think about, like what are the best ways to run your containers today? At AWS, we've been focused on trying to constantly simplify, how you run containers. And we've been running ECS for years. We now for years have also been running EKS. We launched that in June of 2018 to give you a managed Kubernetes experience. And with those, you've been able to run your containers in our AWS regions, from the beginning. And that's been great. But we always hear from our customers, especially customers that have specific use cases, that it would be really nice if we could run containers in our own data center on-prem. They always say on-prem, and that's why I put it in quotes even in the title, because you really have to dive in and ask the customer, what does that mean for you? And so let's just talk about that. What is, who has a definition of what on-prem really means?
I
would say.
Oh, go ahead, Massimo, please.
No. I'm just going to drop it and then I'll let you go. I would say compute pipes that are not in an AWS region, or an extension of an AWS region, meaning wavelength or local zone. Mm-hmm. I would say anything that provides compute capacity that is not located in one of those three environments.
Yeah.
Okay.
Yeah, and abstractly, I like that, because it's not computers or hosts or instances; it's compute resources, right? And I have some experience, as we've talked about in past streams, with on-prem enterprise OS deployment, and sort of racks of servers at customer sites. And people have come to the cloud, and we like to talk about those aspects of why you come to the cloud, and speed and agility and reduced risk and operational efficiency, and all of these are incredible benefits coming to the cloud, but you can't move everything immediately, right? And so we see a lot of that, right, where it's like, well, yeah, but I have this specialized hardware that runs on site, and I want to connect it. I love the cloud, but I have this. Or maybe you have data locality requirements, or you have even things that are bound by law around compliance and health services and financial institutions around the globe. There's different regulations that come into play. So I think, really we're looking at on-prem being really any compute resources that have to be on your premises, in your estate somewhere that is not your cloud estate. And right. But I think that is a critical aspect. It doesn't mean racks of servers all the time. It could be anything. It could be any compute device. It could be custom hardware. It could be Raspberry Pi.
Yeah,
and of course it could be your various managed or self-managed ad hoc bespoke virtualization management. So yeah, there's a lot of things there.
And
we confuse this sometimes with edge and on-prem and data centers, and I think we should just stop talking about all that stuff, because at the end of the day, like, you can get a lot of compute in a broom closet nowadays, and somebody might call that broom closet an edge location. Somebody else might call that just a poorly air-conditioned data center. So I think the reality is, where your applications need to run is outside, anywhere outside the cloud, in my mind, is on-prem. It could be a cruise ship, it could be a satellite, it could be a broom closet at a pig farm in the middle of Kansas, and that's a real use case.
Yeah,
a drone. It could be a drone.
It could be a drone. It could be a drone with a Raspberry Pi duct taped to it. So I did just pick up on something from Justin there, and Chandler, I couldn't agree more. I think You know, one person's broom closet could be another person's DC for sure. And Justin, did you miss OpenStack? I mean, was that not a thing for you? Because I saw a lot of broom closet DCs turned into API accessible data centers. So
It for me, it means whatever, like, because you have it on-prem and you build that to some capacity based on CapEx spending. We're going to buy this amount of capacity. Once you reach that, once that capacity is full, where do you go next? And it's not like I can get infrastructure as code on-prem. VMware has been doing great at that. OpenStack, Kubernetes, like you can do this stuff with APIs and internal CLIs, whatever the case may be, where I can request resources, but once you have to go beyond that capacity, what do you do next? And that's the piece to me that in a lot of cases it's different, where on-prem, that means planning, POs, whatever, if that's storage, if that's compute, whatever it may be. Whereas in a cloud environment, that just might be, hey, one more API call. Like it's either, and I can go, hey, let me build out a new region, right? And like that's an API call, that's not a PO. And so the amount of that cycle of ownership is a lot more on-prem, because you have to worry about power and backup, or like power redundancy and cooling, and those sorts of things come into play. Whereas my API calls to a cloud provider don't need to worry about all that stuff.
Yeah,
Right.
and Tricellum kind of expands on that a little bit. It's also a cost of people and complexity. Where I work, we don't have the internal skill set to run containers well at any scale beyond a single node. And, in a way, that's kind of what we've heard a lot from our customers, and why we've started to expand in this direction, because we want customers to not have to ramp up on skill set and build, tremendous in-house expertise just to be able to run your containers. We want running containers to get easier and meet you there. So we've introduced some things recently that I think can help with that. Who wants to go first? So,
well, I just want to add one thing that we're not talking about, and it's, look, there's companies that have data centers or broom closets, whatever we're going to call them, and they want to move to the cloud. But moving to the cloud can take time, especially when you don't have the staff to do it as fast as you'd like. So, but what if I have, I'm going to call it legacy. If I have my legacy, because legacy in this context is the old, and I want to move to the new, but how can you enable me in my legacy environments to move to the cloud faster? And I think going into what we're about to talk about, with like ECS Anywhere, right? I have the ability now to not have to manage any form of container orchestration clusters. I don't have to think about that, but I can expand to my local data centers to run my services and begin that cloud shift.
And to your point about that, migration takes time, and that's exactly what hybrid cloud is about right now in a lot of cases, where it's like, hey, we know we want to go there, or we want to move some things there, and you can still be in both. And you can say, okay, well, I'm keeping these resources that have to be on-prem or are harder to move on-prem, and then we're going to, use the cloud services for all the things that are either easier to move or make sense, or there's a managed service, whatever the case may be.
And that's a great example of what Brent said, and we're going to get into some of these features and some of these services that we're talking about, is that a lot of, over the last few years, migration to cloud and migration to containers have been synonymous, right? I have my legacy, I have my racks of some vendor hardware that I've paid for. That stuff's in the budget for another 14 months, and it's running, processes maybe in VMs, maybe on Metal. We want to move to the cloud, we want to move to containers, and you sort of have now this gate. You say, well, we can't move to containerizing our application until we can get to the cloud, but we have another 14 months on this Metal that we're spending. So these products, these services that we're going to talk about, maybe even starting just with looking at local zones and kind of connecting, and then getting into some of the other stuff, eventually to something like ECS Anywhere, EKS Anywhere, allows you to knock that gate down and say, let's get into containers right now.
And I'm, just to add to what you're saying, you might be wanting to adopt a cloud native pattern. You might be wanting to adopt, the pattern, a DevOps style pattern. But you have this mental barrier of, to do that, I need, like Justin was saying, that API that lets me provision hardware on demand, and I can bring up and tear down super fast. I have a choice. I can go and build my own or adopt, you know, some third party thing, build my own tooling in my own data center to get that kind of stuff. There are options, but again, now I have to own that. I have to be the expert. What I would really like to do is to go ahead and begin using the AWS APIs and start to use those same APIs, but have them operate against Metal or whatever compute resources I happen to already have in my own data center. So
Tommy F17 just called that out. That was an awesome observation, right? And that leads right to that path. And like we wanna speed you on that path, get you to that on-ramp sooner. And that's what some of these new features and services can do.
Another dimension, though, that I don't want to completely discount is we're talking a lot about migration. Well, there's some workloads that you don't want to migrate. For example, a couple of years ago at reInvent, I remember there was a fantastic video. It was about the Electric Daisy Carnival Music Festival. And they basically travel all around the United States, putting on these amazing music festivals. And what they're doing on site is they're shooting literally terabytes of video. And they need to process that on site. So they're literally moving around all this compute around the United States to process and store this video on location prior to uploading it all into a centralized system. So there are some things that we are in the process of migrating to the cloud. There's some systems where that stuff does need to stay on premise because it needs to be close to whatever physical location where this processing is taking place. And so bridging those two things together, that's where the real magic comes in.
Agreed.
Nice.
I'm almost more interested, at least for the ECS Anywhere use cases that are greenfield on-prem use cases that are like, we think we can't move this to the cloud, or, you know, it needs to be fully disconnected at certain times, or, you know, it has very specific locality requirements. And when you start thinking about all those potential use cases, it starts spiraling like, oh yeah, there's tons of stuff like this, like boats and planes and satellites and, you know, rural
fast food stores.
Yeah.
When we introduced IoT many years ago, there was this the law of physics, the law of speed and stuff like that you cannot literally fight, right? So you want to be in the cloud, but you cannot be in the cloud for every single workload, at least today. Yep.
Well, and to be fair, we have tried to address that by introducing local zones and wavelength, right? So let's just talk about what those are, because those are still relatively new. They aren't new as of, you know, a couple of weeks ago, but they're pretty new, and customers may not be fully aware of them yet. But can someone tell me what is a local zone?
Yeah, so I can start with that. I mean, I like to look at a local zone as a smaller version of an AWS full-fledged region, right? And I think one of the biggest drivers for local zones was customers saying, we want AWS, we want, you know, the AWS APIs, but we need to have a presence that's closer to our broom closets. And I'm sorry, I'm just going to stick with that the whole time.
I love it. Yeah, it's
or massive multi-million dollar data center.
Yes,
like,
right. But
yeah.
Realistically, right? They need that. And gaming customers, this was a use case I just heard all the time, is gaming customers need to be as close to their, you know, the gaming providers need to be as close to their customers as possible. So local zones is a way to enable that. AWS you know, services in a more local area to your data centers, but it's just not as large scale as a typical AWS region.
Yeah, so just like you might be holding out hope that we will be opening a region closer to you someday, now you'd be holding out hope that we might be opening a local zone to you someday. And then there's wavelength, which is, oh, sorry, go ahead, Justin.
Well, one point about the local zones is we did announce a bunch of new ones in reInvent. So I mean, there's what, 5 new ones I think coming out soon. So there are a lot in lots of major areas, and local zones don't have all of the region features of AWS. Typically, a local zone is tied to a region somehow to allow it to do some sort of provisioning or whatever. So the resources and services available in a local zone are smaller. But like Adam's points, if you want 12 of them, wow, I didn't even realize how many. If you do need a lot of compute, or you need something that is like more of the like base features right now, local zones can fit into Adam's point. Like, I mean, rendering is another one where it's like we used NFS in the past, and NFS isn't good at high latency. So I can't necessarily just like, oh, I'm in California, let me go spin it up in Virginia. NFS will just work. It's like, no, NFS doesn't work that way. So having a local zone meant I brought my, my speed of light limitation there from even like Oregon's like 8 milliseconds or something, or 13 milliseconds for me, down to like 2 milliseconds. And I'm like, oh, NFS is fine for that, and then I don't need caching and I don't need all this other stuff. So local zones are great for some of the lower level features if you need compute or stuff like that.
Yeah. So, and then we have wavelength, which is also a localized area, but it's dedicated to 5G and customers that need wireless connectivity. So you can get a more localized experience with that compute as well. And then I think it was Alex Smasha that has already mentioned Outposts. So what's Outpost? That's also an option for customers today.
So yeah, Outposts are cool. So that's basically a rack of AWS hardware running AWS software. It's effectively a rack of what you would see in our data centers that can be delivered to your data center. And there you get to have like ultimate locality for that connection. And you're running AWS services on the same hardware, and it fully integrates back to the cloud. So that's a really super cool project and program.
Yeah.
And I think that it's important to call out here that Outpost is still a service, right? So it's not hardware in the sense that, going back to what Justin was saying, that you have to create a PO to get it, right? It's still a service we provide to the customer, AWS managed. And I think that this distinction is important as we talk more about the Anywhere, asterisk Anywhere products and services that we're going to discuss.
Yeah, for sure. That's a really good one. I sort of glossed over that. Thank you, Massimo. That's when I said it's the same hardware and software, literally the thing works the same way, which means, you can file, sort of service requests or whatever, and have, have your capacities changed, and, sort of the fault mechanisms and how things are repaired are exactly the same. So you're not in there hands-on, right?
I like to think of it as reserved instances, but for all of AWS or for all of whatever Outpost can run in my data center, because it's not like I can bring an Outpost up and then kill it, a minute later. That's not the way it works. But it is something that I can, provision in my account and eventually begin to use it. And there's a commitment behind it, but it's similar to the way you commit to reserved instances. So I really...
You need control plane access, though, is still required, right? So this is not something that's like offline. You still need, the Outpost still talks to the AWS control plane and all that. So just something else to consider when talking about this. Also, Outpost. So, Jesse described it as the large rack, that was Outposts, when it first came out. And now at reInvent, we announced the 1U and 2U servers that you can just, rack in yourselves, which is really cool as well. Like, I'm trying to find a reason to order a 1U Outpost for my house. I don't know.
You have an empty broom closet.
That's right.
Actually, where I am, it's about 20 degrees right now. I could just use an additional heater. So I just put that right at my feet, crank some work up.
I'm thinking of putting one, I want the 2U, and I'm thinking of putting one in the garage just because I don't want to have to listen to it. But at the same time, like, I do want the compute. So I think that's going to be awesome once it's finally available.
Now, those still require 220, right? I mean, this is still like a rack mount. Like, I still need special hookups and stuff like that. So, like, the other option here, even going smaller, is like a Snowball, which does offer you know, some compute capacity.
No, wait.
And,
Well, so tell people.
Do you think I don't have a 60 amp twist lock right by my feet? I mean, because I do.
Yeah, I have a car that needs charging, so I can just go from plugging. You know, I'll unplug my Outpost and plug in the car.
Now, when can you just compute right on the Tesla? Like, that's what I actually want to know. I mean, they have a lot of GPUs in there. Like, Tesla, open up that API and just.
Is it compatible with ECS Anywhere? That would be amazing.
It runs
truly anywhere.
Literally anywhere.
Has 4G and GPUs on it. Why not?
Yeah, totally. So Tricelium says, still in some cases, it's cheaper than hiring a Kubernetes expert to run containers in your company. And yeah, and don't forget, just, you know, humans have to scale too. You can't hire just one expert. They take vacations. So you need to have 2 experts or 3 experts to, you know, to manage on calls and things like that. So it's definitely something that I'm not saying don't do that. It's good to have experts. However, you know, try and shrink that gap between what you have and what you need. And one way to do that is by using something like an Outpost or a 1U or 2U Outpost. Or tell us about Snowball, Justin.
I mean, I don't have it yet, but they do have snowballs. You can get them with compute. I mean, typically they were launched for high bandwidth data transfers, right? Like you can't beat the bandwidth of a station wagon, basically, right? So like you can fill it with hard drives, locally plug in everything over high connections with, you know, fiber and everything else. Push all your data to a bunch of hard drives, ship it to Amazon. But Outposts also support local compute at a certain sense. They have the snowballs, they have snow cones, they have different levels of how much compute and storage you can get, but you can load a snowball with AMIs and then connect it to your account and run VMs on it locally.
So did you order a snowmobile or a snowball?
I was just going to say, that's a wonderful segue to talk about one of my favorite products, which is the Snowmobile, which is an exabyte scale on-prem storage solution. Amazing.
It's basically, yeah, a data center on wheels, right? So that's incredible. And I don't know if there's ever a use case where you would do that, you know, for an extended period of time. Like I was living in New York City when the Hurricane Sandy came through and destroyed most of downtown, and there were a bunch of buildings evacuated, and there was a data center down there that was just constantly having to run on backup fuel because they didn't have power. And I was imagining, and maybe it's part of their plan today, but think about if you are a data center, you could now, through the use of Snowmobile, you could have a plan to have a backup data center driven to you so that, you know, you could, if you knew we're going to be down for a long period of time, let's start the migration into our data center on wheels and then drive to a safer area. Like, that's really cool.
If I can just throw this out there, because I'd be remiss in doing this to my old Sun crew and not calling out that we actually had something like that at Sun 12 or 15 years ago. It was actually a shipping container that were really cool. They were flat black and they had the Sun logo on the side, and literally they were little data centers, and you just bring them right on-prem. And we had a hurricane situation where exactly that was pretty cool. My favorite was one that got airlifted to the top of a skyscraper and dropped. It was pretty cool. I'm not sure if that was photoshopped or not, but I'm going to pretend like it was real. And I think that was just the coolest.
So
let's talk about some container stuff.
But hang on, just on the snow really quick. Am I freezing again?
No, you're good.
Okay. On the topic of snow, but it is, you run compute. So you provision, you know, your EC2, your AMIs, you can launch EC2 instances on your snowballs. As well as you can trigger Lambda functions. So and that use case Nathan was talking about with the carnivals, the EDCs, they were using snowballs to accomplish that local, you know, compute, transform that data, and then when they were ready to ship it, they, you know, plugged in Ethernet and shipped that data to the cloud. So, or just actually sent the snowball back, and then we did it for them.
We also got EKS distro, which we'll talk about in a second, running on Snow as well. So that's something you can run on the Snow devices, is actually Kubernetes itself.
We should just talk about that.
Well, yeah, I mean, and that's what's next, right? So all of this is all about getting closer to where you really need to be. But next up, what if you have compute, you have your data center? What are the options for like dropping directly into your data center and using the existing compute you already have? So these are some options that we introduced at reInvent as well. So there's ECS Anywhere and EKS Anywhere. Who wants to talk about? Let's talk about EKS Anywhere first, and
Okay.
let's just define it. What is it?
Yeah. So basically, you have EKS, which is a widely popular Kubernetes service. We think it's the best place in the world to run Kubernetes, period. So if you want to deploy containers and you want to use Kubernetes, you should use EKS. But like we were saying at the beginning of the show, there's tons of reasons why people need to run workloads outside of the traditional cloud. I'm using the word traditional cloud now. I wouldn't have said that like 6 years ago, but outside of the traditional cloud, you still have workloads that you need help with. And if you want to leverage Kubernetes in those environments as well, our customers asked us to help them do that basically. And that's what it's really EKS distro. And you can't talk about EKS Anywhere without also talking about EKS distro. So that was EKS distro was kind of our first volley into that space to help our customers. And we said, hey, look, we can't get you EKS Anywhere, which is going to be this full-fledged turnkey Kubernetes solution for your data centers today. But what we can do is take the bits that are under EKS today, the exact same binaries, the exact same container images that make up EKS, the core of EKS, and we can open source those for you. And so that's what we did with EKS distro. And there's not an installer around it. We have some docs around how to use, COPS or some other popular projects to actually install the distro. But we also partnered with, I think, 20 other Kubernetes companies like your Ranchers and your Rafes, like all the typical platforms and installers out there in the ecosystem who can help you use EKS distro under their platforms. So that was our first step into the pond. And then the big leap is EKS Anywhere, which is coming out next year. And that's really going to be kind of your turnkey solution. We're going to wrap it EKS distro with an installer. We're going to start putting on all the other goodies you need outside of just the core bits to run Kubernetes in a production-like way. So network overlays and all those types of things.
That's going to be really cool. But even like Justin showed us, was it the day of launch, Justin, that you showed us Kind running EKS distro? If not the day of, it was like the next day or something. So, like having that available to us today, I've already used it several times to validate, hey, I'm going to make this change to eksworkshop.com. And rather than spinning up the full environment, it was obvious to me all I needed to do was just have the EKS or the Kubernetes API available to me, and I could just simply bring up a Kind cluster running EKS distro and test my change and then tear it right back down. And that has already started to pay off dividends. It's awesome.
And one cool thing we're going to do with EKS distro, which is a small thing, but I really like it personally, is we're going to publish an SNS topic that you can subscribe to. So you'll get notified when there's a new release. So we might let's say we bump a version of Core DNS or something. You'll get notified, but how you get notified, the actual data in that notification message will be a CRD. So it'll look like a Kubernetes, resource definition file, like a YAML basically. And you could have, technically, this is what I would do, which I think is pretty cool. You could have your dev cluster listening for that. And then you could write some controller that's like, oh, when we get a new release on this topic, just react to that and bump like the version of Core DNS. And you could have all this done automatically so that you wake up, we release a bumped version of Core DNS, and you wake up and your dev cluster has already run a bunch of conformance tests against that. And you're like, oh, cool.
I sense an open source project coming up.
Yeah.
I think it's cool. Just the fact that we're publishing the SNS topic and we're publishing it in the form of a CRD, I think it's cool because it just opens up the world of possibilities for your internal teams to consume that and react to it basically in an automated way. So
it's CD via CRD.
That's right.
Wow. Like I would have to Google those terms. That's too many letters. But yeah, I mean, like just continuous delivery straight from the vendor, super simple. Like you mentioned, doing it to your dev cluster lets you test, validate, all the things that you need to do, and then just on an ongoing basis, you could then go ahead and release that to your production clusters.
Absolutely.
So that would be
and
awesome.
Upgrades are generally probably one of the hardest things you do as an operator of these clusters. That's why EKS is so popular, is we handle the control plane for you. And so, when you're doing that yourself and you're trying to manage these upgrades, it's challenging. And this is like one step in the right direction to kind of help people stay on top of their upgrades. It just makes it a tiny bit easier to start. And then with EKS Anywhere,
it's really
make that a lot easier.
It's really forward thinking. Like that's just really it's going to be so easy to plug it into. And like Nathan said, it's an invitation to innovation right there. I think it's really cool. And yeah, that rhymed. I didn't do that on purpose, but you can quote me.
If you've been around AWS, I'm speaking to the audience now. If you've been around AWS for any length of time, you've started to notice probably that we have a bunch of two pizza teams, and they often will, do things in very similar ways, but they're still independent teams, and they'll arrive at similar conclusions. So this actually happened for us because while EKS Anywhere was being developed by one team, by Chandler's team, and being worked on, we also separately on a different team were working on ECS Anywhere as well. And so, who wants to talk about ECS Anywhere? Just tell us what's the idea behind it, and how would the customer go about using it?
So the idea behind ECS Anywhere is that you get to benefit from a fully AWS managed control plane and just connect your hardware to the AWS control plane and put it under AWS management. And it's super fascinating. The idea is that I don't have to worry about the control plane anymore. The control plane is being automatically upgraded by AWS behind the scenes. We talked a little bit about how you could automate that with the EKS Anywhere distro. But in this case, there's actually AWS engineers who are managing the control plane and updating that. And they're the ones who are on call if anything goes wrong. And that control plane is just connecting down to your hardware to send commands to it. And you're responsible for running an ECS agent on your machine, which connects back to the cloud and essentially turns it into a little extension with its own IAM roles that it can fetch and everything else as if it was there inside your data center, basically.
That's awesome. So you have all this compute in your data center. You know that you want to begin to move to the cloud, run containers, use the AWS APIs. You can do that by just talking directly to the AWS ECS API, the Amazon ECS API, and then have it talk back to just an ECS agent running on your compute. Like that's really simple, right?
Yes,
about as simple as it can get.
And this goes back to what we were talking about earlier. So I have a data center and I have a use case where I need to access resources in my data center. Rather than having to deploy my virtual machines in the closest region, whatever that is, I can just use that existing hardware, use the virtual machines I have on site, and those can now run containers through ECS. So if I need to access local resources, a local NFS share, whatever that is, I'm very close to my data now. I'm right there.
And I know, so this has been announced. It's not available just yet. However, I know you guys have worked up a demo of ECS Anywhere. So whose screen am I going to share?
Justin's first, probably.
All right.
So, and I did want to add one thing too, that just the fundamental differences here with EKS Anywhere, ECS Anywhere of the managed control plane. This is, allowing us to bring worker nodes into your data center, and EKS Anywhere doing actual control plane if you need to. There still are physical limits and reasons you may not want to do some of these things, such as latency. This demo here is actually a really bad idea to do if you're running production off of something like this. So
We're
just
full of bad ideas.
Yeah, it's just pointing out this is for an example use case of how simple some of this is, but at the same time, some of the limitations here, where you can see this top table here I have with we're describing our container instances in an ECS cluster, and we have the agents. We also have its mixed architecture because Nathan and Adam have some Raspberry Pis, and I have a spare laptop. So we have mixed architecture here, and then we just named these data centers with right now 0 connectivity between them. So this isn't like something that's like, oh, I can migrate workloads from one to the no. It's not necessarily working like that because my node can't talk to Nathan's in New York, which Adam and I are down here in Southern California, and like our latency to like migrate data or something would be terrible. So absolutely think about how you need to use this stuff. But for something that like, I want to throw some random jobs and do compute somewhere, some of that stuff is something you could do. We also just gave some random host names here. You can see these are all through managed instances, which is Session Manager allows you to have on-prem managed instances. This is something you can do today. Don't need ECS, don't need it. You can actually just say, hey, I want to manage my instances and get session management services on your local instances. So I gave a demo of this back in June about using Session Manager instead of SSH for on-prem and for cloud. So you could say, hey,
can I just interject and correct one thing real quick? Yeah. So if people are looking this up, it's actually a systems
manager, Session Manager.
Yeah, systems manager. Yeah.
There's too many managers in it, but
confusing. Yeah, not confusing at all.
Right. But this, just looking at this table, this is, AWS CLI just doing a watch. And anytime we have, you can see Adams is running a job right now. I don't remember what job that is. We do have some task definitions. So if I run a task here, I had one called pod info, which is a demo, container that runs. I think, did yours get it? I saw your memory flash there. So your CPU and memory, this is what's available essentially. So we'll wait for ECS to basically schedule that to one of our nodes, and it'll show up here on how many tasks are running. There it is. Yeah, yours. So we can, something like this is a super simple thing. I saw a question earlier about load balancers. Again, none of this is actually connected to have load balancers or exposed in any way. These are just running a workload on these instances and also showing off, again, cross architecture, using the same spec, using the same definition. We can see that some of them will occasionally land on my box, but it's kind of like a container roulette right now, where it's whoever gets it is just the lucky one that is running a random Nginx server.
Yeah, and
I would like to call out that this is a native ECS task, meaning that this task has a task role and the task execution role. So if you're talking back to AWS services, the task role will be able to say this task and this container can talk to this SQSQ, for example, or whatever, or S3 bucket or anything. So this is first-class citizen when it comes to the AWS APIs and the AWS objects.
That's a great point. And by the way, Justin, your task, I'm watching in real time. I'm just on my Raspberry Pi watching Docker PS. Justin's pod info node just ran on mine.
I just popped your screen up.
And Justin, if you can launch that task again, not the pod info, launch
the region ping.
The region ping task.
Yeah, launching it now.
Cool. And so basically you can see there's a couple things happening. Yep, Justin just launched that task. It was short-lived and it's done. I also have a long-running task where I'm looping through the code. But anyways, you can see I have an ECS agent. This is a Raspberry Pi. I mean, nothing crazy, nothing fancy here, but using the native AWS, the ECS constructs, as Massimo mentioned, we're deploying containers to our local Raspberry Pi data centers.
And as far as the workflow change goes, I noticed in Justin's command, it was, what was it? Launch type external.
Yeah.
Was that really the only change? I'm not saying that's all you had to do, but as far as like when it comes to changing the way you launch something, is that it?
Yeah.
Yes.
Wow.
Yes.
Yeah, Massimo has a great talk at reInvent. Go find his talk on how he explains a lot of this more in detail. But essentially, yeah, it's a new capability that is added into ECS, and you're able to specify, I want this to be external, and that's how your instances, when they register themselves as external instances.
Yeah.
And
So this is the first iteration that we have done from a development perspective. So we added a new launch type and the new compatibility external, in addition to EC2 and Fargate, which has been existing for a while. And we intend to also add capacity provider support to these. So they will be able to manage these external capacity with capacity providers as well.
That's very
awesome.
cool. And
I can tell whenever a container actually hits my Raspberry
Pi,
Pi, because I feel a little fan kick on.
I'm gonna try and feature.
Can we just call out how dope this little cluster on his desktop is? Like, that is so cool.
Yeah, that's pretty great. So
See if I
you
can get the
have,
mic over there so you can hear the fan sound.
so describe your cluster for the audience.
Actually, that's a nice.
So what we got here is we got 4 Raspberry Pis, and there's the Raspberry Pi 4D model, so it's got 4 processors and 8 gigabytes of memory. So we're looking at a 16 CPU, 32 gigabyte memory cluster here that can run tasks. And as we mentioned earlier, one of my favorite things about this is that this has a lot of the features that you get when you're natively running in Fargate or on EC2, most notably the fact that you can actually get task IAM roles. So I didn't have to actually, and this is one of my favorite things, I didn't have to actually put any AWS credentials onto these Raspberry Pis. I just registered them with AWS Systems Manager so that they became managed instances. And then I ran an automated command which caused Systems Manager to provision these Raspberry Pis as ECS instances with the ECS agent. And from that point forward, now whenever I launch that task, they automatically get temporary short-lived IAM credentials that allow them to make AWS API calls on behalf of the application. I never had to actually touch these and run an AWS configure or get like IAM credentials. That's all automated, and it's all secured by those short-term, short-lived credentials.
And so this is just another reason why you should watch Massimo's demo, because Massimo in his demo talks to SQS, EFS, and the way his tasks get permissions to talk is through IAM, which is all managed through ECS. There's no credentials on the Raspberry Pis. He's not hard coding them anywhere. We're using IAM roles, attaching them to the tasks to make those calls and allow those API calls to happen. So we'll find the link for that and post Massimo.
I'm almost there. I
just posted it in the chat.
Perfect. Who's doing it? Brent?
Yeah, 1 second.
Okay. Cool.
I wanted to add also something along the lines of what Justin was saying at the beginning of this demo. I think that what you saw here and what Chandler said when he described EKS Anywhere and EKS Distro built on top of the philosophy that we're using for EKS and ECS. So ECS is over-indexing on simplicity and ease of use, whereas EKS is over-indexing on flexibility and extensibility, right? So this whole notion that with EKS Anywhere, you have to instantiate the control plane closer to the data plane in your data center. For some customers is, well, this is too much complexity for me. And for others, it's like, this is what I need to build what I need, right? So for example, fully disconnected cluster that leaves wherever, right? Whereas for ECS, we took a different path. Like, since ECS is all about ease of use and simplicity, we want to keep as much as possible inside the cloud so that our engineers are your SREs, so to speak, as Nathan was alluding to. And the only thing that you need to do is installing the ECS agent and the SSM agent on those managed instances, right? So it does have more limitation when it comes to comparing this to EKS Anywhere, like it needs to be connected, right, to work properly. But it's more simple.
I do want to interject on that a little bit. What we mean by connected to function properly. So I can actually disconnect the uplink on my switch here, and all of these Raspberry Pis will continue running my ECS tasks, and they'll continue functioning locally. However, I wouldn't be able to schedule anything new onto these because the control plane is running over the internet on the AWS region. I have to communicate to the AWS region, and the region has to communicate down to my Raspberry Pis. Whereas if I was running the EKS Anywhere, I would be able to have a local control plane internally where I could actually schedule new pods onto my hardware, even if I was fully disconnected from the cloud. So that is the small caveat there.
Yeah,
but my workloads would continue running though. So.
And with that freedom comes responsibility, right? I mean, like, again, you're managing a data plane locally in the data center. So it depends on how much flexibility and ownership you want.
Love that.
The point. That's exactly the point, because for some customers, even that is too much, and they may want to need to use an outpost for that, right? AWS managed capacity instead of customer managed capacity. So, yeah.
Yeah. So there's a ton of options available to you as a customer today. And like Justin and Massimo were just summarizing, it's all about how much responsibility you want and how much flexibility do you need. And but it does seem like there's something there for everyone, right? And we know our customers aren't all one thing. So our customers, in fact, even within a single customer, there are often use cases that will demand multiple solutions. So I like that there are now a lot of solutions available, a lot of flexibility, a lot of choices that the customer can make. So I look forward to all of the anywheres. Really getting my hands on that and seeing how it works. I'm going to have to build my own Raspberry Pi cluster now just to keep up with you guys. So, but yeah, I hope that this has enlightened you just a little bit and help you decide, what path you want to go down with managing your compute. Cool.
Bingo.
All right, so I've linked to Massimo's talk in the chat, and I'll pop it up here on screen real quick. It's definitely worth checking out. It's a reInvent 2020 talk, so go get it and see how we're thinking about running containers. And until tomorrow, I hope everyone has a great day.
Thanks, everyone.
Yeah. Bye-bye.
See ya.